Okay, today we're looking at day 2 of section 2.4, and we're narrowing our search for factors. I don't know if I think after we get a list of them today, you're going to be looking at it's like, Bloom, how is this narrowed? We're looking for rational factors here when I'm talking about that. Do you guys remember you take the leading term, okay, and the y-intercept term, and you find possible rational factors based on those combinations. Okay, and we did that last week, and we're going to remind you again about that. But we're looking more so today. Say I got my calculator window here. If it actually comes up, there it is. I got my calculator window here. How do I know that this function, these are all the zeros in the picture? Okay, and on a range, in your x range for your picture, okay, we're looking at our interval from C to D here. What they're saying is our impossible zeros. And we have a lower bound and an upper bound. And we're going to learn about the restrictions, how we know something is definitely an upper bound and how we know something is definitely a lower bound. So that way I don't have to keep like zooming out on my window just to see the whole function, to see where it tails off. I know we have end, what's happening as x approaches negative infinity and positive infinity, and what happens to the function as it gets there. Okay, so when we're talking about its end behavior, that's really about lower and upper bounds. Okay, but this is a lower and upper bounds that we have a test for when we're looking at our division skills. Now, if I have a function, I can set a lower and upper bound in a range. Okay, and how I know it's a lower and upper bound. Okay, if let f be a polynomial function of degree, and the n's got to be greater than 1 as we go through. And let me fix my board as we're getting this because it's misbehaving again. So we got this n behavior with a positive leading coefficient. Okay, so suppose f of x is divided by x minus k using synthetic division. So I have whatever function, I've got k in there because it's minus k, and I've got entries in here, and I'm going to find out what's going on. Well, if I'm doing synthetic division, if it's going to be an upper bound, if k is the upper bound, greater than 0, okay, and every number in the last line is a non-negative, okay, every number in the last line is non-negative. Could be positive, could be 0, but none of them will be negative. Then k is the upper bound for that, okay? That's k is as big as any 0 I could find. Now, if it's going to be a lower bound, if it's less than 0, okay, if it's going, on that lower bound, okay, and the numbers of the last line are alternately non-negative and non-positive, and people are like, Bloom, that's just like math teachers really confusing people. What's a non-negative number? 0 or positive numbers, okay? A non-positive number is negative or 0, okay, when we're looking at those. So when they say non-negative, they're saying positive and 0. When they're saying non-positive, saying negatives and 0, alternately as we look through our final results in our synthetic division. So then k is a lower bound, if that's true. So this is what's going on. We're going to be given opportunities to check this out. So first of all, I'm going to make sure I have my function, and I'm going to look at it and inspect my powers. I want to make sure my powers are in decreasing order. Okay, that's the first thing. And then I'm like, okay, I'm supposed to prove that the real zeros here must lie in the interval of -2 to 5. So I'm going to use -2 and 5, okay, as my lower and upper bound. And I think I took 5 when I did this. I like doing this so I stay out of your way. So I got 4, 3, 2, 1, 0 as far as everything's in order. I don't have to have a 0 as a placeholder when I'm working on my synthetic division. Okay. Now, I've got my 5 in there. I'm wondering, is 5 an upper bound? And remember the restrictions for my upper bound. okay, it's, and you know, we're looking at it's non-negative. It's either positive or 0 in every entry when I finally divide by 5, okay? So I drop my 2, multiply by 5, maybe I drop my 2 and multiply by 5 and I get 10. So I get 3, okay, after I add. Well, I got 6, because, excuse me, 6, what am I thinking? I've got 15, and I've got 7, okay? So I got 35, and I got 49, and that's 220, 245, and 253. Are you okay with how I'm getting my numbers? Okay, and some people are like, all right, we're happy. Now, are they all non-negatives? Okay, this is a test for us to see if it's all non-negatives. If they are, when k is greater than 0, when we're talking about the upper bound, okay, the last line is all non-negatives, so 5 is upper bound for real zeros of f of x, whatever that is, okay? It's the upper bound. And really what it's saying is I have a extreme side on upper and lower bound. My real zeros should be between them, okay? As I do the check. Now, it's your turn. Pop in -2. Same numbers. Check to see if it's a lower bound. Okay, so go ahead and do the synthetic division on that. Check your lower bound. I'll get out of your way there. I find a better door than window. I've been going to yoga and trying to channel my inner window. It just comes out door. I think I need to go back more. Or wall. Depends how close I am to you. Now again, all this was set up previously in the problem. They just want me to show them I understand the check for upper and lower bound when I see a problem like this. They're just wondering, can they do the steps? Can they go through the process of checking using synthetic division? So I pop my 2 down, wherever that is. -2 times 2 should give me a -4. I get -11. And now I got -2 times -11, which is going to give me 22, and I add that in, and now I add, and that's 14. But now -2 is 28, it's -28, and I combine them, and I got 28 at the end, but it actually turns into a 36 for my result. And look at that, I'm alternating, okay? I'm alternating as I go through non-negative and non-positives. And remember, that phrase, that non-negative, non-positive phrase, is allowing us to have 0 in there, okay? It includes 0. It's a funny way of saying it's including 0. I'm sure you'll come across the text sometimes that'll be different. But our final conclusion here, thank you, sir. When k is less than or equal to 0, numbers alternately non-negative, are alternately non-negative and non-positive. Boy, I still can't write that. It should have been numbers alternate non-negative, non-positive. Let's see if I can actually make that fix. Non-positive. So -2 is a lower bound for the real zeros of f of x. And we're talking about real zeros, okay, as we go through. So we're talking about, you know, rational, irrational, they'll both be covered in that range. Okay, now, let's look at the picture of the function. It kind of makes sense. We go over here, and this window is -2 to 5, and we're just doing this check to see, hey, do I really need to expand the window? Okay, and as I go through, and folks, all I'm really doing is that factor theorem, or, you know, if I wanted to find out if something was actually a remainder, I plug 5 into the function itself, but, you know, I'm checking synthetically about the whole list of possibilities of my entries. Now, I'm going to use this next one for a twofold. I don't think they even tell us to, but I want to because I want to make sure I review this. They're asking us to find all the real zeros. But what I want you to do is find all the possible zeros. Are you okay with the difference? What's possible zeros and what the real ones are? Okay, I want to list the possibles, and this will be something I'll ask you to be able to do, whether it be a quiz or test. And what I do is I check my y-intercept and my initial value. And I also got to check to make sure my powers are in order. And people are like, God, why does you do that? Because I'm telling you, I'm going to give you something that's out of order. Okay, I promise it'll happen. Okay, ACT, SAT, MCA, they'll do it too. So check them. All right. So I got 8 and 2. So 8 and 2. But now I have to look at all the possible factors of 8 and the possible factors of 2, the plus or minus ones. Okay, so these are all the factors I'm going to do combinations of. So I've got a set of combinations, and people are like, well, how did you come up with these factors, Bloom? 1 times 8 is 8. 2 times 4 is 8. That's how I came up with it. Hey, and look, 1 times 2 is 2. That one was really a fun one. That was quick. Okay, but I have to consider the positive version and negative version of those factors. So when I'm coming up with the list, remember it's a division. So I'm just going to cover up the 2 there. I'm covering up 2 in class for those folks at home that are like, that you guys don't see anything different. But I'm covering up the 2, so maybe I will cover up the 2 with a polygon here, if it ever comes up. It's working a lot like I do, folks, real slow today. Maybe we won't do that. Here, let's cover it up this way. We'll do it a different way. There we go. Well, let's cover it up. We're covering up 2 right off the bat, okay? And what I want you to do is plus or minus 1 divided by plus or minus 1 will give me plus or minus 1 as a one factor. Plus or minus 1 going into plus or minus 2 gives me plus or minus 2 as a factor. Plus or minus 4 as a factor, and plus or minus 8 as a factor. That's in my list. Okay, 1, 2, 4, and 8. Those are all in my list. Okay, those are possible factors I have to check, or may have to check, because I'm going to be honest with y'all. Okay, now this is a possible list of factors that are rational. Now the next thing, I'm going to get rid of my cover up. Okay, so I've covered up that plus or minus 2. Now I got to consider that. Plus or minus 2 going into plus or minus 1, that's 1/2. That is not on this list that I've already have, so I got to add that one. But plus or minus 2 divided by plus or minus 2 is plus or minus 1. Plus or minus 4 divided by plus or minus 2 is plus or minus 2. Plus or minus 8 divided by plus or minus 2 is plus or minus 4. I already got the rest of the factors. So these are all the ones I need to check. And now here's the trick of it. Okay, when I was doing this, I was like, hey, you know, you could put it into list L1, you know, plus or minus 1, plus or minus 2, put them all in, and then check to see if they're going to be factors, you know, using the remainder theorem. And the one that comes out to be 0 totally works. But then I started looking at it, it's like, you know, if I got my calculator in my hand, why don't I just look at the picture of the graph and check the picture of the graph and see, of the list, which ones should I go to first? Because that'd be faster, right? So of the list, which one should I go to first if I check my graph out? And I don't have that up there, but 4 was one of them. Okay, so I just put that stuff into my calculator, and 4 is one of them. So I bought 4 in, and I got 2, -7, -8, 14, and 8. And every time I do this, I like to check, because boy, you know, one sign error, one wrong insertion of a power that should have had a 0 between them really adds time to these problems. So now I drop 2. Okay, so I got my 2 down there, I multiply it by 4, and I get 8. Okay, so I get my 8, and I add, and I get 1, so I multiply by 4, and I get 4. Add again, I get -4. I multiply by 4, I get -16. Okay, I got -2 as a result, and I have -8, and gosh, look at that. As I surmised, 4 was one of them. Okay, it was on my list, but it was also where I checked my graph to help me find the faster way of doing it. I'm doing okay. But now this is 2x cubed, 1x squared, -4x, minus 2 right now. This is a cubic. I'm going to pick another one. Okay, well, you know, this is on my list, and it was 0.5. 1/2, negative 1/2 was one of them. When I looked at the picture of my graph, negative 1/2 was one of the ones that could be possible. So I thought, hey, I'm going to try that one too. Okay. So I've got this going on, and again, this is not working. Best laid plans of mice and men. So I got negative 0.5 times 2 is negative 1. I add them, I get 0. And I get 0 again, because negative 0.5 times 0 is 0, so I put 0 up. And now I got negative 4 and 0. Well, that's negative 4. Half of negative 4 is 2, but man, it's positive 2 because it's a negative and a negative. And I got another 0. Well, that's pretty rock solid. Are there any questions about what I did on those two? And remember, I took my exhaustive list, I put the function in a calculator, looked at the results, and picked out the top two that I was going to do. Okay? Now, this next one, what I have resulting here is 2x squared minus 4, right? 2x squared minus 4. So let's talk about that in of itself, that I have that function, those factors. And I pulled that 2x squared minus 4 because I can quickly factor that. Okay, and I'm going to do a little funky thing with this. You know that 2 is a real big pain in the butt. I want to have leading terms of 1. That makes life easier. I'd like to have integers. That makes it nice. I'm going to take 2 out of this one. Okay, and you're going to notice an intermediate value. I'm going to have x minus 4. You ready? Set. Do you see where I put my 2? One of these things has changed for the better, right? I don't have that half in there. I just took a 2 out of this, so I went 2x squared minus 2. I took this 2, multiplied it to there, so I could deal with my next step, okay, to make it all pretty. Now, why did I do that? Sometimes on an AP or in a multiple choice exam, when you're asked the factor, they'll have this broken down, but it's easier to break this down as a difference of 2 squares and 2 square roots, really, without having that leading term of 2 in front. So I took the initiative and made it easy for me for my next step. So now I've got x minus 4. I've got 2x plus 1. I've got x minus the square root of 2 and x plus the square root of 2. Now please keep in mind the first 2 I was able to find, no problem. They're in my list. The last 2 aren't in my list. They're irrational factors. Okay, and that trick that I did was possible rationals. Okay, not irrationals. So just keep that in mind as we're working through these. So my zeros, as I go through, I think I'm supposed to find my zeros. I've got the real zeros of f of x are 4, negative 0.5, that is supposed to be a point, and it's supposed to be because it's negative 1/2, and plus or minus the square root of 2. Are we doing okay? Now remember, we talked about upper bounds, we talked about lower bounds, and now we're looking at finding real zeros of polynomial functions. Rational, and now they're irrational friends. And there might be a trend here with partners with the irrationals. We'll see what's going on with that. The board's kind of thinking it's taking time today. Now, again, a polynomial function cannot have more real zeros than its degree, but it can have fewer real zeros than its degree. When a polynomial has fewer real zeros than its degree, the upper and lower bound tests help you know that we have found them all. You can also look at the picture, but remember, the picture itself gives you just your window vision into that picture. Okay, we also got to consider end behavior of the function and look at it as it approaches negative infinity, and be able to test, okay, what's going on with our function, and to help us with the conclusion that we have found all our zeros. Okay, But now again, I want you to come up with the possible factors. Okay. I've got A naught, AN's the leading term. A naught's my y-intercept. When everything is 0, it's the only thing that's left. Okay. So using those two, come up with the factors. I need a list of factors. And people are like, really? I was like, I'm going to expect you to be able to come up with a list of factors. It's one of the things that I'm curious about. So go ahead and do that for 8. This is our last example of the day. The factors of 6, the values that make 6, 1 and 6, 2 and 3, the factors that make 10, 1 and 10, 2 and 5. Look at those combinations. How many will there be? Be thorough. And then again, to check them, I'm asking for a list of possible real zeros. To check them, check out the actual graph of the function to tell you which ones you're going to go to first. There are going to be a couple that you can't guess at because they are not rational. So we got to use our rational ones to help us find the irrational ones. Again, as I go through, I got 6 and 10, so I got the factors there. Those are the things I'm going to be working with. 1, 2, 3, and 6, 1, 2, 5, and 10. And I first divide everything on top by 1. So I got 1, 2, 3, and 6 right off the bat. And then I've got divide by 2. So I got 1/2, and then I got 1 again, 3 halves, and I got 3 again. So I only included with 2, that one and that one. Okay? And then I got 5. Well, I didn't have a 5 yet, so everything is divided by 5. That's why I did that. And then I had 5 and I had 2, so combinations with the 10, and the only one that's different are those ones there with the 10. I got 1/10, 3/10 because I have 1/5 already doubled, and then I had 3/5 already taken care of when I divided by 5. That's why I'm only checking them once. I'm not going to check it again just because it's in the list. Okay. Now, I'm looking at the picture. It's 1. Okay. 1's a great one as I'm going through. Okay, so I'm taking down 10, multiply by 10, my 1, because remember now I've got 10, 0, 0, -3, 1, and 6. And keep in mind why I have 0, 0, because it's going to be 10x to the 5th plus 0x to the 4th plus 0x to the 3rd minus 3x squared plus x minus 6 is really my function. Just that those leading terms, those coefficients I should say with the x to the 4th and x to the 3rd power are just zeros. And that's why I had to pad them out. So check out the remainder on that. Check those. Get that one done. Bless you. Now remember, we're checking right now to see if 0 and 1 are my extremes. 0 being my lower bound, 1 being my upper bound. Okay? To make sure that I got all the possible factors going on in there between 0 and 1. I can look at the possible factors between 0 and 1. I've got 1, I've got a half, I got plus or minus 1/5, I have plus or minus 2/5, plus or minus 3/5, plus or minus 1/10, plus or minus 3/10. So those are the ones that I'd have to consider, okay, as I go through. So again, finding the real zeros of polynomial functions, and I'm proving that they lie in that interval between 0 and 1. And I'm finding them all. So I found them all, but I'm proving the ones that I really want are just between 0 and 1. Okay, so multiply by 1, 10, got 10 again by 1, 10 add 0, 10 again, 1, hey, that's 7, and 7, that's going to be 8, and I get this last one, and I got 2. But now, keep in mind, every one of them is positive or non-negative, but they're positive or 0. So I'm guaranteeing that's the upper bound. Okay, I got 0 going on. They're saying, hey, 0 is going to be lower bound on this function. And then we're looking at 10, 0. That's going to be 0 times 0 is a 0 again times 0. Okay, if I can get this going, maybe we'll write it down because it's be easier everybody see. And then I got times 0, I got -3 times 0 is 1 times 0 again is 0, I got -6. Now, non-negative, non-positive, alternating. Okay, remember that non-negative, non-positive. I start with a positive, but I have a negative or 0. A positive or 0 is next, a negative or 0, a positive or 0, a negative or 0. So I have that alternation on my lower bound, so I can come to the conclusion that those things, are going okay. And we're going to check the graphing calculator to find out where we start. But again, this 1 and 0 were upper and lower bounds, and that's how we know. And I've got that lower bound set up. Bless you, as I talk about them. Now, when k is less than 0, the numbers in the last line are alternating non-negative and non-positive. So 0 is a lower bound. My last thing here, f of x has no rational zeros. If we look at that and we look at the picture, okay, and I actually found them using my 0 function in my calculator. And I am allowing notes to go fast because all I did was graph the function and then do my 0 function. Where does it cross the axis? So I'm not going to slow that down unless you want to have that. I can show you in person if you're not sure. We just had that on our 3rd test just this last week. So make sure you know that that's what the case was. And that 0.95055 was one of them. Okay, checking by calculator. Okay, so I got irrational 0. I just can't deal with it. It's just totally itself. It's irrational. Okay, I'm kidding. All right, that's what I got for notes today. The assignment is up on the board. I have not changed it in Schoology. It will get changed so that way it matches what we're covering on a daily basis. And I think that'll cover it. And I got day 3 that'll be up on Schoology and fixed as well. Make sure you're using your time. Please try to be quiet. I do have a couple people doing a test. And you guys have what, 18 minutes or 28 minutes, I should say, is it, to get some stuff done. Okay, so make sure you're focused on getting that stuff done. Oh, I lied. It's 8 minutes, so it's 23 minutes. Okay, so see what we can do.